Hello, everybody. Welcome to our index law, our lessons on index law, should I say. Now, before we begin, I'm doing this at home, and so these are my two little ladies that are poking their heads in. Please excuse them. Get out of here. Now, what we're going to do today is we're going to recap index laws, and we're also going to look at, should I say, indices, and then we're going to look at index laws. Now, to start off with, we're all familiar with this idea of something, just say 2a to the power of something. And in this case, I'm just using n. I just want to recap that the names of each of these. Okay, so we remember the a itself is the base, and the base never changes. The n is what we call the index or the power, and the number at the front we call the coefficient. And we're kind of comfortable with this idea of 2a2 cubed times 3a squared. And in class we would say, okay, so that's numbers times numbers, so that's 2 times 3, which equals 6. A cubed times a squared, so there's 3 here, there's 2 there, and we end up with a to the power of 5. Now, in this case, we're all cool with this, I hope. But we see that the a doesn't change. It's just the number of a's that changes. And so that leads us very nicely into our first index law. Now, my advice to you is to take notes, because each little box that I've got in green is a summary of everything that we need to do. So we're multiplying terms with the same base. We just add the powers together. And here's our little description of that. If I've got a cubed times a to the 4, or should I say the proof of it, that's a times a times a times a times a times a times a. So what's the difference between that times and that times? Literally nothing. So that's just the same, a times a times a times a times a times a times a, which is a to the power of 7. So let's practically apply that. So like I said before, if we've got 2x cubed times 3x to the power of 4, it's actually the same as any other multiplication of algebraic expressions. So we do our numbers times our numbers, or we multiply our coefficients, which is 2 times 3, which is 6. And then we have x to the power of 3 times by x to the power of 4. Now, before we would just say, well, how many have we got on this side? How many have we got on this side? And then add it together. But now because we know of our index law, a to the n times a to the n is just a to the n plus n. In other words, we just add our indices. It ends up being x to the 3 plus 4, which is 6x to the power of 7. Boom! And it's always that. And that's what our index laws are. They're just rules that allow us to basically just do shortcuts. And so let's now make it a little bit more complicated. If I've got 2ab cubed times 7a squared b squared, we see that we've got two bases here. We've got a's and we've got b's. Now that's a little bit intense, but the fact of the matter is it's the same with each base. So we just do a's added together, b's added together, and we multiply our coefficients as usual. So this would be 2 times 7 is 14. Now we have a times a squared. Oh, this is a little bit complicated because this a actually has a power and it's not there. Anything that is just by itself, we can assume is a to the power of, you know the answer, a to the power of 1. So this is just like saying a to the power of 1 plus 2, and then now we do the b's. B to the power of 3 plus 2. So what we have is 14 a to the 1 plus 2, which is a cubed. And we have b to the 3 plus 2, which is to the power of 5. So all of these are going to be pretty much the same. So now we look at the opposite of times, which is divide. Okay, and it's exactly the same, except rather than multiplying, should I say adding together the indices, in other words, adding the n and the m, when we divide, we subtract the n and the m. And so it's pretty standard here. We've got a to the power of 5 divided by a to the power of 4. So back in the day, we would have put this as a fraction, and then we would have said, okay, 1 from the top, 1 from the bottom. 1 from the top, 1 from the bottom. And we would have been left with 1a in the top, as we say in class, in heaven. And so what we're left with is a, or a to the power of 1. We usually leave out the powers of 1. Now we don't need to do that anymore. We don't need to cancel out, because we know that a to the power of 5 divided by a to the power of 4 is just a to the 5 minus 4, which is a to the 1, or just a. Easy peasy lemon squeezy, eat a slug and make me wheezy? Yes, I think so. And so, let's have a look. So let's have a look at these other ones here. Okay, 6m to the power of 4 divided by 2m squared is exactly the same as what we would before. First and foremost, we deal with the coefficients. That's just 6 divided by 2. So 6 divided by 2 is 3. And now we see that m to the power of 4 and divided by m squared is just m to the 4 minus 2. And so that ends up being 3m to the power of 2, or 3m squared. Now again, I've just decided to complicate it a little bit here and put 1 with 2, so you can barely see that, 2 pronumerals there, or 2 bases, which is the word that we're using at the moment. And so if we've got 3f squared b divided by 9f squared b squared, all of a sudden we come into a little bit of bother. Before, we would have just put that as a fraction. We would have said 3f squared b over 9f squared b squared. We would have said, okay, f squared cancels, 1b off the top, 1b off the bottom, and we would have said divide that by 3, divide that by 3, and we're left with 3 on the bottom and a b, and when there's nothing up the top, what do we put? 1! So that's 1 over 3b. Now we're going to learn something a little bit different, because we're going to introduce this idea of negative indices, and this will lead on to next lessons that we've done. Now we can just do 3 divided by 9, which is just a third, f to the power of 2 minus 2, and b to the power of 1 minus b to the power of 2, which is just b to the 1 minus 2. And so what we're left with is 1/3 f to the power of 0, b to the negative 1. Now, if that's what you got, well, that's correct. But next lesson, or in a couple of lessons' time, we're going to see anything to the power of 0 just equals 1. And we'll go through a whole lesson about that. And so it's just 1/3, if it's 1, b to the minus 1. And I will absolutely say to you now that these are exactly the same, and we'll see why in a few lessons' time. So let's recap. This is our coefficient, this is our base, and this is our power. And when we use our index laws, when we multiply two indices together, or two terms with the same base, I beg your pardon, all we do is add the indices. And when we divide two terms with the same base, all we do is subtract the indices. These are very important and very, very worth copying down and making the mass big, protein, big and fat in your textbook books. Okay, thank you. Thank you, Mike.